Hi guys. Because we ran out of time yesterday, I wanted to take just 5 minutes to talk about the problem that we were looking at the end of class. That problem was the 2009 number 5, and we were specifically looking at part D here. We are given information about f in a table, and we're told that it is also twice differentiable, which implies, of course, that it is continuous. And we are told this information as well, that f prime of 5 is equal to 3 and f double prime is less than 0 in this closed interval. And now they tell us to do two things. First, to use the line tangent to show that f of 7 is less than or equal to 4, and then use the secant line for the graph to show that f of 7 is greater than or equal to 4/3. Well, it's not immediately obvious how these statements, how these things are related, the tangent line and the secant line. So we're going to begin to unlock that question by trying to draw a quick sketch on the interval between 5 and 8. So we'll do a quick sketch between 5 and 8. We know that f of 5 is -2 and f of 8 is 3. And we're going to try to draw the curve so that it has a negative second derivative, that is, so that it's concave down, just like that. That gives us a preliminary understanding of what's going on. Then we're going to construct the tangent line, and to construct the tangent line we need slope and a point. So for the tangent line, we're going to say that y equals f of 5 plus f prime of 5 times x minus 5. And from the table, f of 5 is -2, and from the given information, f prime of 5 is 3. So that this is our tangent line. Now, they tell us to use that tangent line to show that f of 7 is less than or equal to 4. I still can't quite see exactly how it's going to work out, but I am going to estimate f of 7 with my tangent line. So, let me give myself a little bit of space to work here. Our tangent line so far is this guy. And this tangent line is approximately equal to f of x for x is close to 5. Is 7 close to 5? Well, I wouldn't say that it's very close, but they want me to estimate f of 7, so I'm going to pretend that it is close. F of 7 is approximately -2 plus 3 times 7 minus 5. And when we simplify this, we get 4. Aha! This is a good thing, because the question asked me to show that f of 7 was less than or equal to 4, and I just got 4 as my estimate for f of 7. Now the question is, how do I know that f of 7 is definitely less than that estimate? Well, let's go back to our graph here. Here's 7, here's f of 7, and what we know is that the curve is concave down. I just drew the wrong tangent line there. There we go. The curve is concave down, and we drew for ourselves a tangent line at x equals 5. And look at that. Because the curve is concave down, it lies below its tangent line. And therefore, because f is concave down, or another way of saying that is f double prime is less than 0. F of 7 is less than the tangent estimate. Okay, that's the first part. Now the second part asks us to use the secant line to show that f of 7 is greater than or equal to 4/3. Okay. Again, I don't fully know how this is going to work out, but I can construct the secant line. And to do that, I need slope and point. to get the slope, I go back to the graph and I draw my secant line. And my secant line is going to have a slope of f of 8 minus f of 5 over 8 minus 5, which is going to be 3 minus negative 2 all over 3, or 5/3. What about a point? Well, actually, I have 2 points. I have this point 5, negative 2, and this point 8, comma 3, and both of them will give me the same equation for the line. So let me go back to where I have some more space. We've already computed that the slope is 5/3, and we'll take a point to be 5, comma negative 2, so that y minus y1 equals slope times x minus x1. And so this is my secant line. And so I figure that it can't hurt to estimate f of 7 using this secant line. So f of 7 is approximately equal to, let's see here, f of 7 plus 2 is approximately equal to 5/3 times 7 minus 5. And solving for f of 7 gives us negative 2 plus 10/3, which is equal to 4/3. Aha! Again, we are fortunate in that when we did the secant line estimate, we get the value that we have right here. And so we ask, well, why should it be the case that my secant line estimate is definitely smaller? We go back to the graph and see, oh, look at that. Because f is concave down, it must pooch out above its secant line. It must be above its secant line. And so we say that because f double prime is less than 0, f of 7 has to be greater than or equal to 4/3. Now this argument we argued from the graph and it was plausible. How would we make this argument more precise? Well, I think that the good people at AP honestly don't care about an amazing amount of precision with this. I think they're going to be satisfied that you have a graph here that shows that your secant line is below the curve because your curve is concave down. Hopefully this is helpful to you.